The Wi-Fi on campus can feel a little bit like magic. When it works, it's seamless, but when it doesn't, it's a total mystery. Well, today we're going to pull back the curtain, we're going to dive into the unseen engineering and really the intelligent design that goes into building a campus network that can handle thousands of students, all at the same time. Let's get into it. We've all been there, right? You're sitting in a huge lecture, trying to take notes or follow along, and suddenly, nothing. You get that spinning wheel of death on your screen, and you just have to wonder, how is it this hard to get a signal in here? It's such a common frustration, and believe me, there are some very specific reasons why it happens. So it really boils down to these three things. First, you've got what's called high client density. Think about it. You're not just competing with other people, you're competing with their phones, their laptops, and their tablets. Then there's the high application demand. Nobody's just checking email anymore. We're all trying to stream video or hop on a conference call. And finally, when all those devices try to talk at once, it creates this massive traffic jam in the airwaves. That's what engineers call radio frequency interference, or RF interference. All right, so here's our game plan. We've kind of touched on the problem. Next up, we're going to break down how you design for all this demand. Then, look at the smart tech that makes it all work. After that, we'll see it in action in some real-world campus spots, and finally, we'll pull it all together. Okay, let's get into the blueprint itself. Because here's the thing, great Wi-Fi isn't about just screwing a bunch of access points to the ceiling and hoping for the best. No way. It's a science, and it all starts with a really careful design process that's all about capacity first, not just coverage. The absolute first step is discovery. Before you can even think about building the network, you have to know who's going to be on it, and more importantly, what they're going to be doing on it. Are they just casually browsing the web? Or is this a film class where everyone's trying to stream 4K video at once? The difference in demand is just massive. And just look at the scale of that demand. Simple web browsing, that's less than 1 megabit per second. But streaming 4K video, that can gobble up over 25 times more bandwidth. And this is so important. You have to design for the most demanding app you expect to see, not just the average one. Okay, next up, you have to know your physical space. A network for a wide open library is totally different than one for a dorm that's full of thick concrete walls. But it's not just about the stuff you can see. You also have to understand the invisible environment, that Wi-Fi superhighway that's all around us in the air. And that's where this Wi-Fi superhighway idea comes in. Think of the old 2.4 gigahertz band as a sleepy country road. It's got just a few lanes and it gets jammed up super easily. But the newer 5 and 6 gigahertz bands, that's a massive superhighway with dozens and dozens of lanes. And here's the takeaway. Modern, high-capacity networks are built to drive almost exclusively on that superhighway. So, how do engineers actually turn all this info into a real plan? Well, it really boils down to these two steps. First, they figure out how much airtime, or network time, each single device needs to hit its performance goal. Then they just multiply that by the number of devices to see how much total capacity they need. And that tells them exactly how many radios or access points to put in that room. Now, that planning is absolutely critical. But modern Wi-Fi also has some incredible tech that helps it manage all this complexity in real time. We're not just talking about hardware here. This is intelligent software that makes the network, self-healing and self-optimizing. Let's take a look at how it actually thinks. At the very heart of this is something called AIOps. That's artificial intelligence for IT operations. Seriously, think of it like the network's brain. It is constantly watching hundreds of different metrics and using machine learning to predict and solve problems, a lot of times before a human even notices there's a slowdown. Another really powerful tool is the client journey. What this does is it lets network admins see the Wi-Fi experience from your perspective. It can literally track your device and see exactly where and why a connection failed. Was it a password problem? An issue getting an IP address? This thing pinpoints the root cause, which just slashes the time it takes to fix things. And of course, you can't forget security. A wireless intrusion prevention system, or WIPS, is like having a dedicated security guard just for the airwaves. It's always scanning for threats, like a rogue access point somebody might plug in their dorm room, or even more serious attacks, and it can shut them down almost instantly. And all this smart software gets supercharged by the latest hardware standard, Wi-Fi 6. It introduces some real game changers. For instance, MU-MIMO is like a librarian who can check out books for multiple students at once. OFDMA is this clever way to split up a Wi-Fi lane to handle lots of small requests super efficiently. And BSS coloring? It's like letting access points have separate conversations at a really loud party. They just ignore each other's chatter. Okay, so theory is great. We've covered the design rules and the smart tech. But now let's see how this all comes together to solve some of the toughest Wi-Fi challenges you'll find on any campus. So first up, let's go right back to where we started, the big lecture hall. This is probably one of the most difficult high-density environments there is. You've got hundreds of people crammed into one space, and every single one of them expects a perfect connection. So let's put some real numbers on it. For our example, we need to support 200 modern devices, all active at the same time. And the performance goal, what's called a service level agreement, is to deliver a solid 3 megabits per second to every single device. That's the puzzle the engineers have to solve. And after running all those capacity calculations we talked about, factoring in the devices, the apps, the environment, the final blueprint calls for exactly this: 3 high-density access points. They have to be placed strategically and configured to work together to handle that insane demand. There's no guesswork here, it's just pure engineering. All right, so that's how you solve for pure density. But what about a totally different kind of challenge? Let's switch gears and head over to the dorms. The problem here isn't hundreds of people in one room, it's dozens of rooms, each one with high-demand users and a big physical barrier. So the needs here are different. We're looking at maybe 10 devices per room, but they want a higher performance goal, say 5 megabits per second, for things like gaming and streaming. But the biggest enemy? The dorm walls. They can absolutely murder a Wi-Fi signal. The goal is simple: get a strong, reliable connection inside every single room. So what's the solution? Well, in this case, the best way to fight physics is to not fight it. Instead of trying to blast a super powerful signal through concrete walls from the hallway, the best practice is to put one access point right inside each room. It guarantees a perfect signal exactly where it's needed most, and it avoids causing interference for the room next door. So we've gone all the way from the problem to the design to seeing it in the real world. Now let's just wrap it all up and summarize the key things that separate a frustrating Wi-Fi network from a fantastic one. Okay, here are the most important takeaways. Number 1, always design for capacity. That's how many users you can support, not just coverage, which is just about signal bars. 2, live on that 5 and 6 gigahertz superhighway. 3, use those smart AI-driven tools to manage the network before problems happen. 4, make sure you use the right number of APs for each specific area. And here's a pro tip: limiting the number of Wi-Fi network names you broadcast actually frees up precious airtime. So I'll leave you with this one question to think about. Is the Wi-Fi where you are just a utility, like electricity or water, or is it an experience? Because when you start thinking of it that way, well, that's the first step to building a network that really truly works for everyone.